Okay, as has been pointed out, my name is Jan Bender. That's me on Twitter, that's my blog, and that's my GitHub account. The blog has lots of nerdy stuff, among other things, but mostly nerdy stuff. I work full-time at Adobe on jQuery Mobile. I am one of the few proud, very lucky to have an open source job. The reason they get an enormous A, red A, is because that's what they pay me to do, and I'm very grateful. Also, if you are a Rubyist and you are looking like you don't already have a job, if you don't have a job, you're doing something wrong. But if you're looking to switch jobs, go to that link. There are Ruby jobs at Adobe. They're not opposed to working remote, and if by some crazy set of circumstances we got enough people together, we could all hang out and work next to each other. Okay, a little bit of motivation. So clearly this is kind of a weird talk. JavaScript is not the first place you think of when you think of computer science-y stuff. So I think some motivation for this is in order. Luckily, I have it. So math is a good thing. So I think everybody, whether we use it day to day in some fashion or another, whether you hated calculus in high school like I did, math is generally a good thing. We use math every day. We benefit from it a lot. I hated math until really recently, actually. I hated calculus. I felt like I didn't like math because I didn't like calculus. But it turns out there's a lot more math than just calculus. So we're going to talk a little bit about that today. And I say that because I don't want you to go into it thinking that, oh God, it's math. Because I think that I'm prone to that too. Just give it a chance, I guess. Give the category theory a chance. So second point of motivation, jQuery is really popular. People use it all over the place. Something like 50% of the top 10,000 websites as ranked by Alexa, deep breath, use jQuery. So lots of people use this. So the benefits that we'll get out of this presentation, that we'll get out of using the category theory, apply broadly. And with this many websites using jQuery, the performance benefit, you can start to think of it not so much as speeding up jQuery, but sort of speeding up JavaScript or speeding up web applications broadly. And finally, everybody likes performance. It makes for a fun presentation. It makes for sexy headlines. Incidentally, my friend pointed out that's the rev meter. That is not how fast you're going. But whatever. It looks right. All right, so let's get into specifics of why we're doing this. Method chains. Okay, so everybody's familiar with how jQuery works. You get some stuff out of the DOM, divs, anchors, spans, whatever, and you manipulate them generally in these kind of fluent chains of methods. So this one's pretty simple. It hides stuff. It adds a class to said stuff. And then it shows the stuff. And when I say stuff, I mean a set of divs. Now, you don't know how big that set is, right? You're just sort of assuming it's all the divs in a page. Now, ostensibly, you're not normally selecting all the divs in a page. But it's a set. So each one of these things has to do that to the entire set. So let's look at each of these specifically. So this is a naive implementation of what hide did. It's a naive implementation of hide. So what does it do? For each of the elements, so that's the map. For each of the elements, it just display none, so they disappear. Okay. Then for add class, for each of the elements, for all of the elements, it adds a class. So simple. I'm not losing. Am I losing anybody yet? Okay, great, good. That's a good sign. There's a lot of places to get lost in this presentation. And then show again, simple. We're just display block. Okay. So, but again, I want to say this. All of these, each one of these, iterates over the entire set of divs, right? So this is where n is 3 in this case for the number of iterations over the entire set of divs, right? So, sort of an obvious optimization that you could make is to kind of squish those all together, right? Reduce that by n-1 iterations over the set of divs. So if we can, and this is generally referred to as loop fusion, but if you can, instead of iterating over it 3 times, just iterate over it once, you're saving those 2 extra iterations, right? So which is a host of things, counter increments and array access and some of these other things. So before I go any further, can we all agree that iterating over that set of divs once is better than iterating over it 3 times?
Yeah.
Does anyone have a problem with that? Okay, good. Good. That's good. That's foundational. Now, I will say one thing though. It's not always obvious that Loop Fusion is better. I think in most cases it will be, but sometimes it's negligible, and if you do it wrong, you can actually screw things up because of the way browsers work with the JIT, right? So you could actually mess up code optimization that's being done at the VM level. So it's not always better, but especially with simple stuff like this, generally speaking, it's better. So, but there are 2 problems with this. So let's say we wanted to do this. So we're doing a lot of this hide, add class, show stuff to a lot of elements, and we decide, well, we did some speed testing, and this will help us out a little bit. There are 2 problems. The first is that you have to know that the internals of hide, add class, and show can be squished together like this. Now, what we have up here is exceptionally naive, right? It's like a one-liner. But that's not actually how hide is implemented. That's not how add class, well, I don't know how add class is implemented. Hide and show are relatively complex. There's a lot of considerations there. So if you're looking at it, it's not obvious that you can pull all that out and shove it into one big method to speed it up, right? So that's the first problem. The second problem is that sticking them together is hard, right? So you could copy and paste them like this. So you just kind of grab the bits, you copy and paste it all together. But you might screw something up by copying and pasting, right? So they're not, the way to say the second problem is they're not composable. We can't take them and stick them together easily so that they become one thing. Is everybody clear on what I mean by the 2 problems here? Okay. Also, I want to say it's okay to raise your hand and ask questions in the middle of this. I actually like a conversational kind of presentation. So, also, in most nerd conferences, it's sort of, you don't want to look like the idiot who asked a question. That's not a problem. This is complex. Like, about a year ago, I wouldn't have understood any of this. So feel free to ask questions. Anyway, okay, so let's get into it. Let's get into the fun stuff. So a little bit of background. And this is the last picture for a long time. So just soak it in, enjoy it. You won't see a lot of them. So there's these 2 guys, Eilenberg and McLean, and they were working on algebra. And I mean that in an inaccurate sense, but they were working on algebras. And what they saw was commonality between the things that they were working on. So what they wanted to do, just like when you're working on your code and you see 2 things that are the same in 2 different places, you abstract it, you pull it out, right? So they were seeing this in the math that they were working on, and they wanted to pull out this behavior. And what they got, and they didn't call it category theory at the time, what they got was some very simple properties of things, mathematical properties of things that apply in all sorts of places. So when I say all sorts of places, I mean programming today, programming, physics, algebra, geometry, all kinds of places. So, and I mean, to me, that's all kinds of places. I don't know. Maybe people think that's all the same thing. I don't know. Science, right? What is it? But it applies all over the place because it's extremely general and abstract. So it even applies in JavaScript, as we'll see today. So that's a little bit of background. So let's get into the nitty-gritty. What is a category? When we're talking about category theory, what do I mean? Okay, a category is a thing. And a category has 2 parts. Well, it has 2 tangible parts. The first equation there is the 2 parts. So the first one is, in a category, you have objects. So that's fairly intuitive for programmers, objects, right? I don't mean it in the sense, category theory doesn't mean it in the sense of like your objects, your Ruby objects or your JavaScript objects or whatever. But those, we will talk about it in that sense. But as far as category theory is concerned, it means just very abstractly things. And that's on purpose. So the second equation is meant to highlight the fact that that's not a function up top, it's just a way of saying the objects of some category C. Okay, so ob C is just the objects of some category C. That's the way it'll be referred to hereafter in the presentation. The second piece is, they're called morphisms. And so it's like, when I read morphisms for the first time, I was like, Jesus, what does that even mean? But it just means actions, mappings, activity. So if you're a programmer, you can think about this in terms of nouns and verbs, kind of, right? And so those are the two things that make up a category: objects and actions, mappings, morphisms. Now, there are a couple things that the category has to do, a couple laws, a couple attributes that it has to have. The first is identity. That's the math. I'm going to skip that and go to the really obvious stuff. So this is what identity looks like in JavaScript. It's that simple. Okay, all it's doing is returning its first argument. It does nothing else. That's it. That's identity. The reason why categories require identity is beyond me. I can find out for you later if you like, but I do not have that answer. Composition. So the actions in the category, the mappings, the morphisms, have to be composed. Now, we talked about this a second ago when we were talking about squishing those things together, right? We talked about composability, right? Putting two things together. Now, this is the purest form of composing two things, two actions. And in JavaScript, it's relatively simple again. So the function compose takes two functions, f and g, and returns a new function that takes a single argument, passes it to the first function, or, well, depending on the order, passes it to g, so I'm not being ambiguous. G processes, does what it does, and then gives the result to f, right there. Okay, so this is really central to the compose thing. Is anybody unclear what I mean when I say composing two functions? All you're doing is piping a value into one function and piping the result into the other one. So you're just stringing them along. Has anybody here used bash?
Yes.
Okay, pipes.
Yes.
Okay, that's you'll often hear people say that these small Unix tools are very composable, because they are. It's easy. It's just strings is the common interface between those two things is strings. So in this case, composition just requires, let me go all the way back here. Composition just requires that the return value of the first function lines up with the first parameter of the second function. So they just can pipe through. Okay, the result can go to the next function. All right, is everybody clear on that? Composition. I really mean this. If you don't understand it, it's totally fine. Raise your hand. Awesome. Okay, good. We're in good shape then. All right, so now we've got the four things that we know are required to create a category. So we've got objects, a set of objects, a set of morphisms, the identity law or attribute, and composition. And there's a subtlety to the composition thing that I'm not going to talk about. But if you're curious about it afterwards, come talk to me. Anyway, that's where we're at. Those are the four things we need. Okay, is everybody clear? Four things. All right, so we're going to find our first category. This one is HTML. So the tradition with categories is that they are 4 letters or less, like set, and the first character is capitalized. So you'll see another one in which you follow that convention anyway. That's why I'm calling it HTML, and you'll see in a second. So the first thing we need is objects, right? So this one's really simple. So the objects in the category HTML are HTML elements. So if you've ever used just the raw JavaScript API in the browser, you get back divs, anchors, whatever. All of those are the objects of HTML. Okay. And when I'm saying these are these things, they are as I have defined them. So these are my categories. So I own them. They're mine. Meaning you won't find this anywhere. These are just things that I came up with in my head. So, and that is to say they follow the laws of a category, and I've had people who know category theory better than I check them, but I did come up with them. Anyway, HTML elements, those are the objects. Morphisms. So again, very simple. The morphisms, the mappings, the actions in the category HTML are just functions that take HTML elements as arguments or as the first argument and return an HTML element, right? So HTML goes in, HTML comes back out. Simple enough? Let's look at an example. So if we're setting the class foo on stuff, it takes an element in, and it alters that class attribute, and then it returns it. Okay, so those are the two things. We got the objects and the morphisms. So we define those in relatively simple terms. Identity, again, identity is exactly the same. The only difference is we're changing that A to an element. We're sort of waving our hands, because there's no type system in JavaScript, right? So we're just waving our hands and saying it has to be an HTML element or one of its child classes. Divs, anchors, spans, whatever. That's identity. Again, just takes one in and returns it back out. Composition. So this is the last one. What does composition look like? It looks exactly the same as just the example that I gave you, right? Because we're not doing anything very special here. This is just JavaScript functions. The only thing we've actually really said that's even very interesting or concrete is just that they have to be HTML elements that are passed in. That's it. We're just sort of making that a law. So again, takes an element, it returns a function that takes an HTML element, pipes it through those two, and then you get a result back. So that's composition in HTML. Okay, so we have all four. We got our objects, which are HTML elements. We got our morphisms, which are just functions that alter those HTML elements. We've got identity, which just returns whatever it's given. And then compose, which just pipes an HTML element through two functions. Okay, is everybody with me? Okay, good, because this one's a little more complex. So this is the second category we're going to talk about tonight, is jQuery. And this one's a little bit more complex because the objects are not simple. They're jQuery objects. So if you've ever worked with jQuery, anytime you do this, you get back a jQuery object. So and the type there is actually sort of inaccurate. If you've ever looked at the type or the constructor of a jQuery object in your inspector, it's actually jQuery.fn.init. So if you've ever done that, I don't want you to be confused. I'm just trying to keep it relatively simple. jQuery objects, simple enough. Okay, what are the morphisms? The morphisms are the methods on jQuery objects you use every day. Hide, add class, show, whatever else you choose to define on .fn. These are the things that alter jQuery objects. Now, the specifically complex part is that this is our parameter, right? So remember that in all if you've ever, how many of you have defined your own jQuery method? So if you, okay, fair number of you. Okay, so I'll explain this. When you define a method on jQuery.fn, you can then use that in the fashion that we just saw, so like this, okay? When the method is invoked, the this will be whatever jQuery object you're calling out. So the this value will be that jQuery object. So in this case, it's sort of a implicit parameter, right? How many of you use Python? Anybody Python? Okay. Self. When you call the function, the first argument is actually the object. So you can use it as a first class function because you can manually pass something in, right? Okay. This is defined for you. So this, whenever it's being used, is that jQuery object. So if you called ID here, it would be that sample jQuery object, okay? That's important. So all it does is return that. Again, ID. It just gets the object and gives it back. So when you call this, you're just going to get back the same jQuery object unaltered. Composition, again, a little bit more complex. Anyone not know what the apply method does for functions? Okay, cool. We'll cover it. I appreciate you raising your hand. More power to you. So composing two of these jQuery methods is a little more complex because we don't have that parameter, right? We can't just easily pass in the first argument and have it kind of shuttled through all the functions. We have to do a little bit more work because this has to get defined somehow. In JavaScript, when you want to define this in an invocation of a function, you use apply. So in the body of G and in the body of F, in these cases, this will be whatever the first argument to apply is. So let's ignore F for a second. So if you do a G.apply this will be, I've done it to myself now. This inside G will be the this that you see here. That sentence is totally trying to think of a clean way to explain it.
Use the term execution context.
Right, okay, that's fine. So it's a context in which it's executed. That's a good way to look at it. Let's assume that we change the this to something else entirely. So let's make it an object. You can even pass in a string here. Okay, and then the this would be the object version of that string. So whatever you give to apply is the first argument will be the value of this inside of G. Is that clear? As clear as mud. My apologies. So, and then the result, because remember we're returning all good jQuery methods return this, the jQuery object. That's sort of a required thing. And so as returning that, then that same value will get applied for f inside of it. So these two functions, G's this value will be set, it'll do some work, it'll return whatever it did, it'll return the alter jQuery object, and then f will get a chance to work on it. In the same way as with HTML, the HTML functions, the HTML morphisms, it's just getting piped through. And in fact, I probably spent too long on this. You don't even really need to worry about this. Just understand that the jQuery object is getting piped through each other, just like the other composition. All right, so the last one, and the big scary word for the presentation this evening, is functor. So functors do this work of bridging a gap. So we have these two categories, right? We've got all four things for both of these categories. And if we want to get from one category to the other, and I'm not expecting you to understand why I want to do this yet. Don't worry, you'll get the aha moment at the end. The thing to use is a functor. That's what it does. It maps from one category to another. So we're going to do that right now for HTML to jQuery. That's what we're going to do. We're going to go from HTML. We're going to take the objects in HTML. We're going to take the morphisms in HTML. And we're going to turn them into objects in jQuery and morphisms in jQuery. Okay, that's all it does. It's just a mapping between the two. So one way to think about it, any HTML morphism, as long as it adheres to those things that we talked about, using the functor can then become a jQuery morphism with this thing. Okay, that's what we're building. So first the objects. So like I said earlier, HTML elements. So just like you would get out of the DOM API. Luckily, this one's really easy. Getting a vanilla HTML element and turning it into a jQuery object is as simple as passing it to the dollar method. A lot of people don't know you could do this. You don't have to pass it a selector. It can be a lot of things, actually. It's a gigantic type union. But you can pass in a plain vanilla HTML element to the dollar method, and you'll get back a jQuery object with that HTML element inside. So that's it right there, right? We just mapped an HTML object into a jQuery object, right? Okay, that's the first part. Second part, we got to get our morphisms from HTML to jQuery. Now this one's a little bit more complex, but it's still pretty simple. So here's our set foo HTML morphism. So this is the thing that just adds foo, like we saw earlier, and alters it, and then returns it. Super simple. How do we turn this into something that can alter a jQuery object? That's what we're trying to do. So let's see what that looks like. This is the goal. We're trying to turn this into, this jQuery object dot set foo, right? We want to be able to do this. That's the goal. That's how we transport those morphisms. So one way to do that is jQuery map. You can do this, and you can reverse those two there. So you can do divs.map with some caveats. But generally speaking, jQuery map is the way to do this. So now with jQuery map, we've taken, and you'll see on the right there that this function is exactly the same as set foo that we passed to map, right? So now we took set foo, and I probably could have just typed set foo there for clarity, but we've taken set foo and we've transported it into something that can alter a jQuery morphism, or can alter a jQuery object. So now it's set foo can now be a jQuery morphism. So we've got our two things. The dollar method for altering objects. So we take our objects in HTML, we give it to the dollar method, and it becomes an object in jQuery. Is that one pretty clear? That one's pretty simple, right? By and large, the two category definitions are not nearly as important as this. If you've been, kind of zoning out a little bit, maybe now's the time to tune in. And if we want to take our morphisms, our functions that alter HTML elements, and turn them into morphisms or functions that alter jQuery objects, we can use map. Is everyone clear on that one? That one's a little more complex, yes?
Why use map?
So, okay, that's a good question. This is a spectacularly good question. So let's go back to it since I want to answer this. With each, it's based entirely on side effects, right? You don't have to return the element, you just alter it, and it's altered, right? Because this is imperative programming, right? It's not pure. Right, so you just make the alteration, it kind of happens. With map, you actually have to return the element. You're required to. Because that may not necessarily be true. But generally speaking, you're supposed to return the thing that's going to fit back into that spot. So with map, you can actually send in all your jQuery elements and return back numbers, like the length of their ID, or you can just return strings. And the jQuery object set will just be strings. So you actually change what's in that array. So it's a mapping. So this is important too, because remember, our HTML morphisms have to return the HTML element, right? That was one of the stipulations. Because otherwise we can't compose them. We can't guarantee that the HTML element has been altered when it gets past the other. So this return statement here at the bottom guarantees composability. It means we can plug them together. It guarantees that the HTML element will get piped through. Now, again, I would point out that because of the side effects, it may not be that important. And that actually kind of helps my case at the end here, because it broadens the things we can optimize. So I used map at the beginning for my examples that we squished together, but those could have just as easily been each, just as you said, right? But they can still be optimized on some level. So anyway, the idea is that map requires the return, and we need the return for composition. So it's just a little more rigor to it, I guess. Does that make sense? Okay, so composition. So this is one of the functor laws. I've kind of pushed one of the other functor laws out, but this is the one that matters. So let's look at the math because it's fun. It makes us feel good because we're looking at math. All right, wonderful. The second equation there is the one that we care about. They're both the same thing. They're just a different way of looking at it. But the one on the bottom is very simple, and if you're a Haskell programmer, you'll recognize it immediately. And let's take a look at what this really means. So I just want to give two examples here. As we said, map just takes a function and runs it over the set, right? So we've got two maps here, strung in a row. And what that is actually saying, what that equation earlier is saying, is that if the functor law holds for these two categories that we've specified, and for this functor that we've created, these things are functionally equivalent. So they will produce exactly the same result. Does everybody see what the difference between these two things is and why that's important? That's two iterations on top and one iteration on the bottom. Okay? So that's a law, a mathematical law that we just adhered to through defining two categories in the functor, which has told us exactly which functions we can compose to reduce our iterations. I see nodding heads, which is really good news. I was not expecting that. So is anybody lost at this point? This point is pretty easy to grasp. You can almost forget it if you just want to trust me about the math. This is the fun stuff. So this is the performance optimization right here. So let's look at it in a slightly different light. So let's kind of abstract it a little. Let's define our jQuery function. Again, when you define a jQuery function, define our $.fn, and then you return this.map. Okay? So the only thing this is doing is just taking those two maps and moving them into reusable functions, right? So these two things are exactly the same. Again, what you see here is exactly what you use day in and day out, right? jQuery functions in a chain being replaced by something that is one jQuery function of two composed methods, or two composed functions. So through the law, we've identified a set of JavaScript functions that we can compose and feel safe about having this nice result. It should, in theory, speed up our code.
Question.
Yes.
In practice, we probably write the second line there as like F sub G open and close paren instead of using the composition function.
I'm not clear what you mean. Let me go back to that.
So it was just the last slide, actually. So you have a composition function to compose them, but in practice, could we just have it be F open paren, like lowercase f open paren G open paren close paren?
You could if you wanted to wrap it inside the map. So like if you want to do it manually, you could define a function here, so an anonymous function, and then inside it just do the pass through yourself. The nice thing about compose is it does that for you. So that's, yes. And it actually, that would be a nice additional slide here for clarity's sake, so I'll remember that. That's a good idea. Okay, so what he said, what he asked was, would you normally just do F, F as an argument to, or A, G, F. So just do the composition yourself sort of manually instead of using the helper. And you can, you just need an anonymous function around it. So if that makes any sense to you. Makes sense to me. All right, so we've kind of gotten it, but let's solidify this by going back to our original result. So for the purposes of going back to our original result and seeing how we're going to do this, I'm going to take out hide just to simplify things, because composing 3 functions together is harder on the eyes than doing it with 2. So is everybody okay with me just removing hide? That's not going to hurt anyone's feelings? Okay, that's good. We'll assume they're hidden on load. So what we want to do is, again, we want to take these and we want to squish them together somehow, in some way. So let's look at this. So again, let's go back over exactly what's happening here. The top line there, the equivalent is mapping over each and every one of them every time these 2 functions. They're our naive add class and our naive hide, or show, sorry. So we've got these 2. These are the things we care about again. We don't really care about all the other stuff that's happening here. This is the stuff that actually does things. And ideally, we'd squish these together and get this back out. This is the ideal. This is what we're looking for. Again, it's hard because we've got these 2 problems where we have to go copy and paste, and we don't really know that that's going to work. But we've got our kind of super weapon here, right? We've been talking about it the whole time. So let's do this by making one change. So instead of just doing the map, vanilla map, let's define these functions globally as far as our conversation is concerned, or in such a way that they're available to us. And then all of a sudden, the only thing that we really have to do, again, to squish those 2 things together is composition. So does everybody see how I got from there to there? Or no, you don't have to see how, just see why that's awesome. Because you don't have to do any copy and pasting, you don't have to go find the code. As long as the pure version, the HTML morphism, is available, you just shove them together via compose and then just use them. You don't have to think about it. Which is good, because that solves both our problems, right? Incidentally, the Unicode character for smiley is drastically different than the Unicode character for the frowny face. I had to do a bunch of really special CSS to get these to look even remotely the same. It's sort of ridiculous. I don't know if you'll ever run into that, but keep in mind. All right, so back to reality. What does this mean? What does this mean for your day-to-day? Because in my opinion, if we talk about all this theory and we've got this nice idea, but we don't do anything about it, it's sort of worthless, right? And the reality, okay, so I missed my time. It's funny that the slide says timing is everything, because I missed my timing on the slide. And that's the reality. Is it available today? Can you do this today? No, it's not. I've gotten a little ahead of myself with this presentation. But that doesn't mean we can't change that. So let's talk about a very simple standard. So this is something I'm going to be at JQCon in San Francisco at the end of June, and I do work on jQuery Mobile. I know a lot of the core team. I don't have any real grand dreams about them accepting any of this, but this is a very simple standard that would allow you to do this in your day-to-day. So very simple. So the first thing we need when we have something like add class. So is everyone familiar with that, with what add class does? Okay, good. Probably over double checking these things, but that's fine. So this is again a naive implementation of add class. So and done in a way that we could pretty easily pull this out and make use of it. So again, it takes the jQuery object set, in this case, which is this, and maps this alteration over it. So that's what it does. It takes it and runs this across all of the elements there. So all we really have to do, let's make some alterations to make this easier. We need to get this thing out. This needs to be outside and available. Again, the availability of this function, the HTML, I'm going to say it again, the HTML morphism is key. So what we do is we pull that out and we call it add class. It should be set foo or something, but you get the point. This needs to be available globally so we can make use of it. And then you can make the exact same add class method just by passing that into map. You don't have to, it's not like a big change, it's just pulling that one piece out. But then this is the key part. If everyone who made a jQuery plugin and everyone who created a core method, so jQuery core included, because a lot of jQuery core is this exact iterative thing. Hide, add class, show are just 3 examples of an enormous library that does lots of iterations for you in this fluid interface, right? So if all of those methods, add class, being an example, expose that underlying bit of alteration. So if they were to first use map and then expose that underlying bit of alteration, the add class function, you'd be able to use it, right? So this composable attribute is really important. So if that was available, this is what it would look like. Well, so there's a little bit of preamble to this. You're sitting down and you've decided, I want to do some basic optimization. You know, let's do some low-hanging fruit for my jQuery-based application, right? And you've got a big list, maybe, of things that you iterate over to alter. One thing you can, and this may not even be something you do on a project, but like open source libraries can take a look, jQuery Mobile being an example, can take a look at their code and say, look, there's these big chains, maybe we can optimize this. So let's look at an example. So we're going to go back to our example again. You're looking at this in your code base and you're saying, that's 2 iterations, why don't we make it 1? So this assumes, of course, that in both cases we have the composable attribute. And then all you have to do when you go through there is replace that chain with this. Now that's less readable, I agree. There's no argument there. But it is faster, and a lot of times when you do performance optimization in your applications, that's what you're giving up. You're giving up abstraction to speed things up. That happens a lot. Moreover, we can take this stuff and make it a lot simpler with a helper. So you can define a simple helper that takes 2 functions and checks to see if they have the composable attribute. So if they've got it, compose and map. And that would look like this. That's a little bit nicer. That's a little bit less painful. And this is just me dicking around with, you know, one idea that I had as far as how to speed this up. Well, actually, I can't take credit for this. I have to be totally clear. Evan Phoenix, my friend that I work with, gave me this idea before I left today. So I liked it, and I incorporated it. Credit to him. Also, if we had that composable attribute, we can monitor chaining within jQuery. We can monkey patch into jQuery to warn the user when they're chaining 3 or 4 times. And there's an implementation of that at the link. So I've actually implemented that. I haven't tested it on a big project, but it's a drop-in. So you drop it in below jQuery, below your jQuery code, specifically below your own custom method definitions. And it will tell you when you're chaining 2 or more times. So you can then go find those places and optimize them. And you know, it's easy to alter this and configure it where it could throw exceptions too, so you can be really strict. You can actually do this automatically if you do it lazily, and I actually set that up. That's in there too. The problem is it's not always obvious that somebody wants to have those things composed. Sometimes there's a timing issue where you want to do other things in between the chains. And specifically, if we go back and look at that example of the squished one, all those things happen to a single element at once. If you wanted to hide everything first, then show, alter everything, and then show everything, which is reasonable, you'd want to leave that the way it is. But if you don't care about the order in which it happens, then you can speed it up. So you can't assume, this is why it has to be a warning, it can't be done for you. You can't assume that people want to fuse these things. Anyway, it's a fun read because it does a lot of JavaScript stuff. Anyway, further reading. So this actually came out of a blog post. That's JavaScript category theory on my blog. And then there's a follow-up on natural transformations, which is just only really if you're interested in the category theory, because there's nothing nearly as interesting as a performance benefit at the end. And that is it. So are there any questions? Yes.
Yeah, see, you didn't speak about category theory and composition outside the context of jQuery. Was that intentional? Because obviously there's a lot of opportunity there.
I coming in this only had 30 minutes, so that's part of it. Category theory, so let me give you an example. So other categories, and this is really important. If you're actually interested in categories, the thing that made it easier for me, category theory, is seeing a bunch of examples so you can build an intuition for what it means. Because it is really abstract, right? It's sort of just this stuff somebody made up, right? And then, we happen to have a nice result from it here, but it's not really stuff somebody made up. There was an impetus behind these things. Okay. So set is the category of sets, where the objects are sets of things. So whatever arbitrary things. And the morphisms are just functions between sets. So that one's actually really simple. That's sort of the oft-given example of a category when you want to explain one. But and the nice thing about this is well, one second. So the nice thing about this is that between this, which is relatively familiar territory, set, and maybe Hask, which is the category of all Haskell types and functions, if you put the effort in, it's almost enough to kind of get you over that. So there are lots of them, though. I mean, there's the category of groups. I mean, there's a bazillion. I mean, there's just tons of them. Groups are sets with operations on specific operations on them, which is where functors get interesting because you're preserving those operations going to and from. I mean, it's very rich, very complex. But yes, there are tons of other categories.
Yeah, I didn't mean to challenge the.
Oh no, not at all. No, that's a really good question. Yeah,
The use case of jQuery. That's not
when
the use case.
I was writing the presentation, I felt like I was pushing it, honestly. So I think I have to dial back a little bit on it. But it looks like I came in mostly under time. So that's probably something I want to add in, maybe into context a bit. It's a good idea.
Kind of help out with this piece. This is less of a question, more of a sharing. In physics and linear algebra and general math, the way you do coordinate transformations is exactly this. Instead of taking some object in the coordinate system A and then applying transform 1 and then transform 2, you multiply the two matrix transformations together and then apply it to your object. So that's a really ground level piece that kind of applies this in an entirely different perspective. Whether you're working in games or physics simulations, all those sorts of things do exactly this.
It's amazing and you probably know more about it than I do. But it's amazing to me how many places it gets used. And when you learn about it, it is really abstract. Like, look at what I said. I said that the things that we needed were objects, things that do things, right? I mean, that's so not concrete, especially in terms of our discussion. I only made it concrete because I have a category or two to show you. But it's incredible the diversity of things that it gets used for. Any other questions before you go? All right, thank you very much.